We are the music makers, and we are the dreamers.
So today we are going to talk about logic. So what is logic? Logic is the basis of all mathematical reasoning and all automated reasoning. The rules of logic specify the meaning of mathematical statements. The rules of logic give precise meaning to mathematical statements. These rules are used to distinguish between valid and invalid mathematical arguments. Apart from its importance in understanding mathematical reasoning, logic has numerous applications in computer science, varying from design of digital circuits to the construction of computer programs and verification of correctness of programs. So what is proposition? Proposition is the basic building block of logic. It is defined as declarative sentence that is either true or false, but not both. The truth value of a proposition is true, denoted as T if it is a true statement, and false, denoted as F if it is a false statement. To represent propositions, propositional variables are used. By convention, these variables are presented by small alphabets, such as P, Q, R, S. The area of logic which deals with propositions are called propositional calculus or propositional logic. It also includes producing new propositions using existing ones. Propositions constructed using one or more propositions are called compound propositions. The propositions are combined together using logical connectives or logical operators. Next, we have the truth table. Since we need to know the value of a proposition in all possible scenarios, we consider all the possible combinations of the propositions which are together joined by logical connectives to form the given compound proposition. This compilation of all possible scenarios in a tabular format is called the truth table. The following are the most common logical connectives in its truth table. First, we have the negation. If P is a proposition, then the negation of P is denoted by not P, or it is not the case that. The truth value of not P is opposite of the truth value of P. Next, I am going to show the truth table of negative P. Second is the conjunction. For any two propositions P and Q, their conjunction is denoted by P and Q. The conjunction P and Q is true when both P and Q are true, otherwise false. This is the truth table of P and Q. Next is disjunction. For any two propositions P and Q, their disjunction is denoted by P or Q. The disjunction P or Q is true when either P or Q is true, otherwise false. This is the truth table of P or Q. Next is implication. For any two propositions P and Q, the statement if P then Q is called an implication. In the implication if P then Q, P is called the hypothesis or antecedent or premise, and Q is called the conclusion or consequence. The implication if P then Q is also called the conditional statement. The implication is false when P is true and Q is false, otherwise it is true. This is the truth table of if P then Q. Lastly, the biconditional or double implication. For any two propositions P and Q, the statement P if and only if Q is called a biconditional and is also called a bi-implication. The implication is true when P and Q have the same truth values and is false otherwise. This is the truth table of P if and only if Q. Well, that is all for logic, and I hope you learned something today.